Evaluate using algebraic identities. Now here we have three algebraic identities: a plus b whole square, which is equal to a square, plus 2ab plus b square. Second algebraic identity is a minus b whole square, which is equal to a square minus 2ab plus b square. And the third algebraic identity is inside the bracket a minus b and another bracket a plus b, and after the product we have a square minus b square. Now in this question, first of all we have to decide which algebraic identity is applicable, and then we have to apply and calculate the result. Now obviously it's a whole square, so that means the third identity is not applicable. Only first and second is, we have to decide which is applicable. Now if we split the inner value, it will be 1000 plus 3, and when we will add, it's a 1003. So that means if it is 1000 plus 3, so this shows the value a and this shows the value b, and inside the bracket, inside the value will be plus sign. So that means we have to apply the first identity. Now here in the first identity, the right hand side will be a square. So here a is 1000, so we will write 1000 whole square plus 2, the value of a is 1000, the value of b is 3, plus, and the value of b is 3 whole square. Now we have to take the square of 1000, and when you take the square of 1000 in that means you are double these values. So inside is a 3 zeros, so after multiplication that's a 6 zeros. So 1 2 3 4 5 6 zeros, plus 3 twos are 6 into 1000 is 6000, then 3 threes are 9. So add vertical wise all these values. So 1 0 1 1, then you have to write 6 zeros, 1 2 3 4 5 6, and then you have to write 6000, and then you will write 10, and then add vertical wise. So it's a 9 0 0 6 0 0 1, and after adding we will write 1 0 0 6 0 0 9. So this is our final answer. So next is 98 square. So here again we have three identities, so we have to decide which identity is applicable in this case. So we will write to the nearest 10 or nearest 100. So if we write 100 and minus 2, so it will be 98. So 98, so this shows that this is the value of a and this is the value of b, and within these two variables we have write minus sign due to this reason, because 100 minus 2, that's why we will write a minus b. So look at this in this shape, and it's already square, so that's why we will apply the second identity. Now the value of a is 100 whole square minus 2, the value of a is 100, the value of b is 2, and then plus the value of b is a square. Now which is further equal to 100 square, means you have to multiply 100 into 2 times, so double the values. So that means we have 4 zeros, minus 2 twos are 4, 4 into 100 is 400, plus 2 twos are 4, and then second is you have to add, and then you will subtract using BODMAS rule. So 1000 plus 4 minus 400, so 1000 plus 4 will be 10004 minus 400. Now subtract vertical wise, minus 40, and when you take the carry from here, it's a 10 times minus 4 is a 6, and the remaining value will be 9, so we will write 9. So the result will be 9, and it's a 0, so 9604, so it will be 9604. So the last one is 97 into 103. So here the value, there is no square, so obviously it's understood that the third property is applicable. But here in this case, it's one value is a minus b, another one is a plus b. So that's why we have to split this value. So firstly we have to select this one. So it's 103. So when we will split this one, it will be 100 plus 3. So 97, automatically the other value will be 100 minus 3, because we are applying this value, so we will choose one value plus, another value negative, but both b's are same, both a's are same. So here both b are 3 and both a's are 100. So we will write these values inside this algebraic identity, but on the other side it's a, after the product it's a square minus b square. So we will substitute the values over here, a square minus b square. So the value of a is 100 whole square minus the value of b is 3 whole square. So it will be, if you multiply 100 into 100, and that means you double the value, so the result, the zeros will be 4 zeros after multiplication of 100 into 100, minus 3 is 9. So subtract vertical wise, and when you subtract, you carry from here, it's a 10, so and here it's a 0, and the remaining value will be 9, 9 and 9. So it's 1999. So finally we have 9991. So this is our required